Page 226, number 16. Construct arguments. A survey found that 27% of high school students and 94% of teachers and school employees drive to school. The ratio of students to employees is about 10-1. Roger states that the number of students who drive to school is greater than the number of teachers and employees who drive to school. Explain how Roger's statement could be correct. So again, this is a reasoning or a thinking problem. And you'll notice down here that the statement says, explain how Roger's statement could be correct. So we're going to look at the information that's given to us, organize it, and then we're going to see if there's a scenario, a situation, a fictitious high school where we can apply the data, the information that we're given, and see if Roger could be correct. So I'm going to break this problem down and try and organize the information that is given to us so that I can wrap my head around it. So the problem tells us that 27% of the students drive at this particular high school, HS's high school, but 94% of the employees, the teachers, the custodians, the administrators, the secretaries, whoever, 94% of them drive. Well, that makes sense. High school students are teenagers. You wouldn't expect as many of them to be driving to high school as you would the employees. The other thing that we want to think about in this problem is that we were given some information about the ratio of students to employees. Now, when you think back to when we talked about ratios, we talked about the order that things are mentioned in the problem and the order that the ratio is represented. So when the word students comes first, when we're talking about the two entities in the ratio, students and employees, and then the ratio itself, 10-1, the first word relates to the first number and the second word relates to the second number. So for every 10 students, there is one employee at this particular high school. So we're going to represent that on our paper as well. We have students and we have employees. Now, the number of students to employees was written out this way, 10-1, but you remember that when we write it so that it is vertical, the 10 is the first term and the 1 is the second term. So we have, for every 10 students, there is one employee. So if I were to double the number of students to 20, I would also double the number of employees, and I would have 2. And I could continue in this manner. If I triple the number of students, I would get 30, and if I triple the number of employees, I would get 3. So the question is, Roger made a statement. Roger's statement was that the number of student drivers was greater than the number of employee drivers. You should pause the video and write that down. Looking back at the information about students and employees that we have, it's a little counterintuitive. In other words, it might be confusing, it might not make sense initially for Roger to say that, because look at the percentage of high school students that are driving. It's much less than the percentage of employees that are driving. However, when you look at the ratio of the number of students to employees, you can see that the number of students is far greater than the number of employees. So this one might think, well, Roger's statement can't be correct because 27% is less than 94%. But this part, this ratio, shows us that there is a ratio of 10 to 1 for students to employees. So this is where we want to use our math, and we want to say, could this be true? Well, let's just make a fictitious high school. And let's say that instead of 10 students in the high school, let's have that number multiplied by 1,000. So let's multiply 10 times 1,000. Here we multiplied it by 2. Here we multiplied it by 3. Well, let's really jump and let's say 10 times 1,000. Well, that would give me 10,000 students. But you know that I also have to multiply my one employee by 1,000 if I'm going to multiply my students by 1,000, and that's going to give me 1,000 employees. So now for every 10,000 students, there's 1,000 employees. Why did I choose 1,000 to multiply by? I chose 1,000 to multiply by because numbers that end in 0 and begin with 1, in other words, powers of 10, are very easy to manipulate and work with. And I also had powers of 10 right here. So I knew that my multiplying would be easy, and my setup for my determining if Roger's statement is true or not should be easy. So what I'm going to do is I'm going to look at these numbers now, and I'm going to find out what 27% of 10,000 is, as well as what 94% of 1,000 is. And then I'll be able to compare those numbers to see if Roger's statement is correct. Before I do that, I just want to point out that this ratio over here is a part-to-part ratio. In other words, part of the humans in the school are students, and part of the humans in the school are employees. But notice I don't have a total number that represents everybody in the school. So this ratio is a part-to-part ratio, the students and the employees. So now I'm going to set up two proportions. I'm going to set up a proportion using my 27% changed into a fraction, and I'm going to set that equal to the number of students that I have in my fictitious school. The other proportion will be set up using the 94% and the number of employees in the school. (27/100) is equal to the number of students I have in the school, the total number of students I have in the school, over how many of them are driving. Notice now I do have a part to whole and I have a part to whole. My other proportion is going to be using the 94% because that's my employees, and I'm going to use my 1,000. So again, this is my part to whole. And over here, I'm going to find the part of all of the employees who are driving. So for both of these, I'm going to solve using cross multiplication. 27 times 10,000. And set that equal to 100 times x. Isolating the x, I'm going to divide each side by 100. And the reason I'm dividing by 100 right now is so that I can save myself a step later. I can divide and cross out these zeros right here and be left with 27 times 100. And 27 times 100, a 1 with 2 zeros after it, is 2,700, or 2,700 would be equal to x. So that's the number of students that would be driving. So now I want to find my adult drivers, my employee drivers. So I'm going to do the same thing using cross multiplication. 100 times x and 94 times 1,000. Again, dividing each side by 100. This is my smaller number. I have 2 zeros there. I can cancel those 2 zeros out and those 2 zeros out. That's dividing by 100. So my x is equal to 94 times 10. 94 times 10 is 940 employee drivers. Our question: explain how Roger's statement could be correct. Well, we just looked at a situation here where we had a fictitious school where we used the ratio of 10:1 to determine the population of the number of students in a school. If we multiplied that ratio by 1,000, both in the first term and the second term. After we got our number of students then in our fictitious school and the number of employees in our fictitious school, then what we did was we used the percents from the surveys, and we were able to discern or determine the number of drivers. So Roger said that the number of student drivers is greater than the number of employee drivers. That is true. This was not an easy problem, and this is not a short explanation. Using the ratio of 10 to 1 students to employees, I found that a possible population of students and employees at a school could be 10,000 students to 1,000 employees. 27% of 10,000 is greater than 94% of 1,000. The number of student drivers is greater.